So first of all, we have the operating system, and we have the Win32 process. Then we have the app domain. Then we have C#. Runtime environment is called CLR, available in app domain. So app domain is a lightweight process. It's just a lightweight process. And runtime environment is available in app domain, right? And all the applications written in .NET like WPF, C# based, all the applications runs in app domain. And all the legacy applications like C++, your Visual Basic, your ASP, these kind of application runs in Win32 process, right? These kind of applications runs within the Win32 process. And the C# based application runs under the app domain process. So there is isolation, separation of concern, the fault tolerance. So if any exception comes in C# application, it won't reflect back to the C++ or Visual C++ application. The reason is this application runs in separate process and your application runs in a separate process, right? In framework 1.0, in 2000, 1.0, 2001, 2000, and 1.1, based application runs in same process, right? Only to run this application, we have CLR. So CLR as a runtime environment, as a virtual operating system, right? For your application, a CLR is a virtual operating system because your application is being managed by the CLR, right? And the runtime environment for Visual Basic or C++, both runtime, all runtime environment was in a same process. There is no fault tolerance, there is no isolation. If any exception comes in C++ program, it can also reflect to the C++ program because runtime environment and the C++ runtime environment in same process. So C# framework 2.0, right? Framework 2.0 is known as 2005. So 2002, 2003, no, 2004 was there. .NET 2000, 2002, 2003, no 4 was there. So framework 2.0 has given a remarkable concept is called app domain. So app domain introduced in a framework 2.0, right, is called 2005 .NET. 2005 .NET was a framework 2.0, 15 years back. So they were given the very remarkable feature is called app domain. So your now C# shifted from the Win32 process to app domain. Separation of concern, loose coupling, no tight coupling. So you can say C# runs in separate process. All the legacy applications runs in your Win32 process. So this is basically a .NET 2005 and framework 2.0. So if any exception comes in this kind of applications, they don't reflect back to the existing applications running in Win32 process. So overall, we got an idea that C# is a managed application because it runs in a separate process. It runs in separate process and managed by the CLR. Okay, C# is basically managed application. The reason is it runs in separate process and being managed by the runtime environment is called CLR. And the CLR is basically written in C++ or in Visual C++ or in C language. So if you want to see where is your CLR, you just go to C drive and do find where is your Windows, System 32 and C drive Windows, C drive, just hold on. C drive Windows, Microsoft.NET, framework, do find framework, version 2.0, 3.0, 3.5, 4.0. You will be getting one library there. It's called MS Cori. MS Cori. This is called CLR. mscori.dll. This is called runtime environment. And there are several DLLs are interlinked to each other for this library. It's a root DLL. As you can see, system.data.dll. There are several dependencies, SQL client, Oracle client. There are several dependencies. So you have several dependencies for this DLL, but root is your MS Cori. Is set to be CLR. It's a runtime environment. Okay, so finally, threading is a feature of your operating system. CLR supports threading, right? Threading is not basically a feature of the C# and Java. It's basically a feature of the operating system, but CLR is managing the thread for your applications, right? If any exception comes in your program, who will manage your exceptions? Again, CLR. If you have taken memory to run the application, once you run the application, you need a memory. And once you close down the application, Sandeep, then you have to return the memory to CLR, or CLR can return to operating system, right? So garbage collection. So again, garbage collection, your exception handling and threading and memory management. These are the major feature of CLR. That's why it is said to be a runtime environment, which is meant for managing the execution of the application. Okay. Right. Now, so finally, to run the application, a memory is needed. True, very true. To run the application, memory is needed. And to run your application, to manage your application, CLR is needed. I just told you, garbage collection, threading, memory management. These are the basically remarkable feature of your CLR, right? Now, so we have the RAM. Actually, memory is a part of RAM, memory, right? And operating system manages those memory, right? And being as a developer, right, we should know when we write a program, so program has multiple elements, program uses multiple elements. So which portion of the program goes to which memory, that's most important for us, just to know. So memory is a part of RAM. And when you run the application, your program needs memory to run the program. Your program needs a memory to run, right? So which portion of the program goes to which memory, that's most important for developers. So for being as a developer, we require two kinds of memory. One we call stack memory, one call stack memory, and second call your heap memory. Second call stack memory, and second call your heap memory. So these two memory, and we require several memory, code memory, cache memory, there are several memory. But to run the program, at least we require two kinds of memory, and these two memory is a part of RAM. Okay, and being managed by the operating system. And CLR smartly handle these kind of memory. But CLR says, I'm supposed to only handle the heap memory. Sure. CLR says broadly, I can manage the heap memory, and whatever Sandeep stack memory is being handled by the operating system. Okay. So garbage collection and CLR. Garbage collection is one of the most feature of CLR. So garbage collection is a feature is being handled by the CLR. So garbage collection will handle the heap memory, not the stack memory. Okay. And Sandeep Karan, what about a stack memory? Execution of function takes place in a stack memory. Execution of function takes place in a stack memory. When a function gets executed, it automatically wash off. So CLR is meant for managing the heap memory, not for stack memory. So when you make a function gets executed, past tense, gets executed. So stack is empty. So who will manage your stack memory? The operating system. Okay. So being as a developer, I should know which portion of the program goes into a stack memory and which portion of the program goes into a heap memory. To know this fact, you should know object-oriented concept. Okay. And C# is a language to manage those concepts. And let us see which portion goes to stack memory, which portion goes to your heap memory, once you know the fact of OOPS. Now, why do we learn OOPS? What's the best part of OOPS? Why do we crazy for OOPS? What it gives you finally? So overall, data. Data is one of the most prominent feature of any software development kit. You go for banking software, you go for travel domain, you go for healthcare, you go for any kind of software. What you do finally? Data. You play with the data, you manage with the data. You manage to data or you play with the data. At last, finally. So my data should be safe from accidental world. No one can directly go for accessing the data without prior notification, right? So overall, OOPS is meant for managing the data. Okay. It's primarily meant for ease the complexities. You can go for normalization in terms of identify the task and you make a class for that. So one class cannot do all the activities. If he does, you break down the single responsibility principle. As we do in database, not only one table is sufficient for defining all the columns we identify. And by the identification, we go for making a one table, second table, then we can think for relationship and all there. Here we say inheritance is a kind of relationship, right? We can say association, we can say aggregation, we can say composition. It's a kind of, a relationship. So being as a developer, we should know the relationship between two classes. Shall I go for association? Shall I go for the association aggregation? Shall I go for the composition? Shall I go for inheritance? It's again a kind of association. It's again kind of relation. So there are multiple ways you can go for defining the relations among or in multiple classes, as we do in database by joins. When to go for self, when to go for inner, when to go for left. Anyway, come back. So overall, the purpose of learning OOPS, my data should be safe. It should be safe from accidental world. No one can go for directly accessing the data without a prior notification. That's the most important part of learning a OOPS, and logically categorize, identify, then categorize. And once you go for categorize, you can get multiple classes. You should know a relationship between those classes by identifying the aggregation, composition, association, inheritance by the relations and all. Anyway, so finally, where to keep my data for the long time for the security? That's most important, Sandeep. Where to keep your data? Not for the long time. You can keep your data at the right place, so it should be safe from outside of the world. Okay. You make your own structure. You make your own structure. You make your own structure. You define your own structure. You define your own structure. right? So there are multiple ways you can go for creating a structure for having a data. It's called data structure. You have multiple ways you can go for creating a structure for defining a data, or for having a data. As we go for defining a structure in table, then we can have a data, right? Then we can go for security of table by DBA. They can secure the table. Who can access your table? He makes accounts. He gives a privileges. He gives a roles and all that. You know. So how your data can be saved? To save for data, I want a structure. Okay. So how you can make a structure for the data? We have a class. So what is class? Shall I say class is a, what do we say? Class is meant for defining the structure. Class is meant for defining the structure. Class is meant for defining the structure. Right? Class is meant for defining the structure. Okay. And Sandeep, a structure needs memory? I said, yes. If you define the structure, you need a memory? I said, yes. So, and same point of time, C# says, what is reference type and what is value type? Same time. C# plays generally with two types. One called reference type and second called value type. Okay. So, object is a reference type and value type is a value type and object. So when you write a class in C#, the compiler is called csc.exe. C# compiler is said to be CSC. And this compiler is available within the Microsoft.build, writing short, Microsoft.build.task namespace. TASKS. Go and try Microsoft.build.task namespace. This namespace is having the class called CSC. Okay. CSC is a class. Yes. And this class is having the base class is called managed compiler. Okay. Managed compiler. Can you show me, Sandeep? I'm so sorry. Open the ID. Just go and find Microsoft.build.task namespace. Don't have so much dependencies in a corporate world. So Microsoft.build.task namespace is carrying the class called CSC, and this class is having the base class called managed compiler. Okay. So the class called compiler called CSC, So when you write a class in C#, compiler internally inject the base class of this class is called object internally. And when you write a struct, it's again a way to define the structure. Okay. So by this struct, we can also define the structure. Why you want to make a structure? For the data management. Okay. Why you want a structure? I want data to be managed. I'm finding a right place to keep my data in right structures. So a struct also allow to create a structure. Okay. No. So when you write a struct, the compiler CSC inject the base class, compiler internally inject the base class is called value type. And second, the compiler internally convert the struct into sealed class. Oh my God. Oh my God. Sure. So please don't mind. I told you, open the ID, you can see. If I try to see, I'm deviating from my topic. So please don't mind, sir. You can watch at your end, you open the VS Code, you can write a struct, you compile, you go for reflection, you can go for diagnosis by the tool called ILDSM, and you can see your struct has been converted into sealed class. Okay. And compiler internally inject the base class of this your class is called value type. Okay. Good. Then after Sandeep, and fortunately, the value type is having the base class called object. Okay. So value type is having the base type is called object. So object is a root type and it has having a two derived type. One is called value type. Sorry, object is a root type. It has having the derived type is called value type. Okay. And when we write a Sandeep class, then compiler will inject the compiler will inject the object as a base type for my type. Okay. Why? Sir, please give me time. Have patience, please. And when you write a struct for creating own structure, the compiler internally inject the base type of this type is value type. But before injecting the base type, compiler called CSC is a compiler having the base class called managed compiler. So what this compiler does, they inject internally the value type for your type. But before injecting a struct internally first prepared himself first, converting into sealed class. Then you got a base type of this type is value type. And value type is having a base type called object. So why compiler, Sandeep, inject a base type for your type as an object? And why compiler inject the base type for your sealed type, struct as a value type? That's a remarkable point. If you know the strength, the mean of value type and object type, then you can understand the importance for creating the structure by struct or by the class. Otherwise, you never know.